Hello, today we continue with CST or cyclic synchronous torque. In previous video we covered changing the controller mode and how to use CSV or cyclic synchronous velocity mode, so that I would suggest that you go there and check it out before you continue with this video. In addition, between last video and this one, I just added this orange background just that we have it a little bit more clear that we are working with axis. Now, how to use a torque and what is CST? Let's now briefly go to EtherCAT manual for our Lexium 32M. So you can see that the drive will follow torque value transmitted on a cyclic basis, and you will see that the controller will have to send this parameter, which equals to a percentage of a stall torque, and the resolution is 0.1%. If we go to the drives manual on page 520, we have a register where we can read out what is the stall torque of our motor, and we have also address where we can find this information. This is going to be very useful in our project just to show how SoftMotion is working and to show you that it's really smart and it's doing the job for you. Now let's go briefly to the function block that we will need to use to control the motor in a torque mode. So function block in question is called SMC set torque. You just enable it and then you send the torque value. However, we see that torque value is not in percentage, but it's in Newton meters, and this is now information which SoftMotion needs to use and send the proper data to a drive. Now let's go to codices and let's start programming. So first of all, what we will do is set this set controller mode, and one thing we did not do in the previous video is to display the real or the actual controller mode that our axis is in. This is quite simple, and for that we will use one text box. We will just copy one of those from our axis control visualization. Ctrl C, Ctrl V. Let's place it here, reduce the size, and in text, real controller mode percentage S. It's going to be enough. And the variable in question is called by real controller mode. And now let's add our function block. First create an instance, SMC set torque axis 01 F2 SMC set torque, and again little cosmetic changes. Now let's call our function block F2 instance call set torque, and we need to add an axis, and again we'll call this visualization. So SMC set torque, we connect the reference to our instance, all traditional thing, enter. So let's log in. Let's run. And as we can see, real controller mode is 3. Now simply let's enable the axis and run it. And before we begin, we need to read out our MM0. So let's do it. 0D subbitness 16 hash 16. And we see that value is 140, and this equals to 1.4 Newton meters, because this value is in Newton centimeters. Now let's execute set controller mode, and we know that if you want to use torque, the value is 1. We showed that in previous video, which is torque, which is velocity, and which is position. So we execute this, and now controller mode is 1, and we see that axis is not moving. So let's put some small value, just that we have axis moving, because now there is no real velocity limitation and the motor can move with the fastest velocity if it has enough torque. So let's put some 0.03, which equals 3 Newton centimeters, and enable. And we see that motor is in fact jerking around, is not really moving. It doesn't have enough torque to manage the friction inside the bearings. So let's increase it by 1 Newton centimeter. And now we have motor moving. It's not as smooth as it can be, but now we have 0.04, which equals 4 Newton centimeters. Now let's see how this equals to our target torque. For that we will need to use a calculator. So if we simply put 0.04 and we divide this by 1.4, and if we multiply this with 100, we will get percentage. And if we multiply this with 10, we will have 0.1%. Our value that we send to a drive should be 28. In fact, the decimal value is higher than 0.5, so it should be 29, which would equal 2.9% of our stalled torque. Let's open our drive. Let's go to mapping, target torque, and we are sending 29. So our calculation is correct. SoftMotion axis does complete job for us. That's it for today. Thank you for watching. If you like this video, please give it a thumbs up. Don't forget to subscribe, and I'll catch you in the next video. Bye.